Okay, guys, thanks very much for your patience. We will get started now. So by way of introduction, I'm Norrie, I'm the commercial director at 3D Repo, and I guess I'll be kind of the host for today's webinar. Let me just share my screen and we'll get on with the presentation. So today's webinar, we're going to be looking at 3D Repo for change management. We've got quite a packed lineup to go through. So I'll be starting off today with introductions. I'm the commercial director at 3D Repo, looking at how the 3D Repo platform in general and what it is and how it works. Then I'll be passing over to our head of digital twins and product manager, Matthew Osment, who'll be looking at a bit of an introduction to change management, what the issues are that surround it and how we've been looking to solve those issues. We'll then pass over to Bogdan Davydov, who's our customer success manager, for a bit of a live demonstration, taking us through some of the features that Matt might have hinted against in his presentation. And then finally, we're really grateful to have Burton here from Atkins to talk about Hinkley Point C and how they've been using 3D Repo for their change management process. So we'll save that till the end. And then at the end, we will have a Q&A session. So keep the questions coming in. There is a Q&A feature built into the Teams live sessions. We'll be monitoring that throughout. We might type back some quick answers if it's a really quick question, but we'll save the good ones till the end for a bit of a panel discussion amongst the four of us and everyone else who wants to get involved. So by way of an introduction, for those of you that don't know 3D Repo, we are a BIM platform. So we're a cloud-based platform for ingesting and managing BIM data. We work by allowing you to upload your BIM files in any of the popular file formats, native or open source file formats such as IFC. It goes up into our cloud system where we store them. We break them down and store them in a database for analysis and viewing. On top of this platform, we've created a platform called 3D Repo IO, which is what we'll be mainly looking at today. This platform is built around the idea of bringing together models into single federations, running analysis on them for things like change detection, but also many more things that there'll be a series of other webinars on, such as clash detection. There was one a few weeks ago on health and safety risk management. That's all available through the website. There's a recording. If anyone's interested in that, let us know. But we will also be running further presentations on other areas such as data validation and takeoff and that type of thing. Uniquely to 3D Repo, really, in this space, we have a really open API that goes out to lots of different platforms. We'll be showing a bit of this today, I believe, in the live demonstration connecting out to Power BI. But this really opens up a world of possibilities with ingesting data into 3D Repo and taking data out for further analysis in any of your normal analysis tools. So looking at 3D Repo, this is what it looks like when you log in. You get everything together. So here we're federating multiple models from obviously King's Cross Station, and you saw some GIS mapping underneath there as well. We have an API for that. And the idea is that everyone can log on to a single source of truth, wander around the model, mark it up, identify issues, run any of these type of analysis that we'll be showing today, such as the change detection. And it really offers an easy to use web-based platform for anyone to access the BIM data without the need for expensive or hard to use software such as the normal BIM software as Navisworks and Revit. In terms of what we do for integrating, we do a lot of work in-house. So we have plugins for things like Revit and Navisworks. We've just released a really interesting product that I'll show in a minute called Planbase that links to the platform around allowing people to comment on your designs. Initially, this has been done with the Mayor of London around the idea of democratising the planning process, but there are many other use cases for it as well. And then we've developed all these links out like what we'll be showing today for Power BI for really analysing the data within the database. But I think even more interestingly than that, we do a lot of partnerships. So we partner with multiple companies to integrate our technology with theirs and allow for flexible workflows of data either coming into 3D Repo or flowing out of it, such as multi-screen VR that we have for Mission Room. Unit 9 have developed an AR iPad app which pulls data directly from 3D Repo. We can do custom tools such as the one done by Quadrital for a digital twin that uses 3D Repo's backend to create custom UI and applications. And we can link out to existing data collection systems such as EveryFile to be able to pull data directly into 3D Repo or visualize the model within their data collection system. So just to talk through a couple of these, so the plan-based one, this is an example of that. So it allows you to pull models from 3D Repo and put it into a really easy to use web-based interface. That in this case, we're asking people questions about the scheme that's being designed and getting feedback on it, as well as allowing them to navigate around the model in a really easy to use web-based platform and explore what their local community could look like if this development goes ahead. And then just to show one of the ones that I spoke about in-house, this is the AR app that's been developed by Unit 9. So this is pulling data directly from the 3D Repo cloud onto a mobile device and allowing you to overlay that in augmented reality on site to look at the kind of as-built versus the planned. Yeah. So just a bit about 3D Repo in terms of security. We're a UK government approved supplier, so you can procure us through the government G Cloud. We have ISO 9001 and 27001 in terms of quality management and security management. Everything's done through extended validation certificates. So on the front end, you're secure, and all the data is encrypted on the database and encrypted via HTTPS when you are accessing it via your web browser. Finally, the hosting options. So everything that 3D Repo does that you access through 3D Repo IO at the moment is hosted in London on AWS. There is also a separate version in Montreal for any of our North American users. But we can, if needed, spin up 3D Repo on any private cloud of the major hosting or on premise if that's something that you really need as well for high security projects. So just a really quick overview of 3D Repo as a whole, the whole platform. Now we're going to really focus in on the topic of today's webinar, and I'm going to hand over to Matt to talk you through an introduction to change management and where we see the issues with this.
Thanks, Andrew. Let me just share my screen now. Hi, everyone. My name is Matthew Osment. As Andrew introduced me earlier, I'm the head of digital twins and product manager at 3D Repo. I've recently moved to 3D Repo. I've actually spent the last 6 or 7 years in the industry working on projects like Hinkley Point C, Battersea Power Station and Crossrail. So hopefully some of this comes from a project background rather than a software background. So first of all, PwC released a report a few years ago, but stating that changes in scope are the biggest contributor of construction project failure. And I think that's something that a lot of us who work on projects see. We understand it, but it's hard to quantify it. It's hard to see the full effects of how change disrupts and causes issues on a project. And those can typically be categorized in these 5 categories. Obviously, there's more. And the key thing here is that every single one of these aspects has a time impact and a cost impact contractually. Whether that time impact and cost impact is in fact £0 and 0 days, or thousands of pounds, millions of pounds and 0 days, or vice versa, it's important to understand that there is always an impact. And the key to 3D Repo and modern BIM workflows in this use case is how do we reduce those impacts? How do we neaten up the workflows? So the first way in which using 3D models and 3D Repo can help is identification. And Stephen's going to go into more detail about this later, about how they've been doing it on Hinkley Point C. But the key thing is changes in design are much easier to visualize in 3D because you can do a lot more. One model could be represented by 300 drawings. So if you have to go through 300 drawings to check for changes versus one model, I know what I'd prefer to do. The next key aspect of 3D models is communication. Again, going back to that example of 300 drawings, if you find one change in a 3D model, you can tag it up and communicate it quickly with the rest of the team. Whereas if you found that in a drawing, you'd have to go through, mark up the drawings, make sure you were sending them to the right place. You would probably end up with lots of different versions of the same drawings. So let's go back to those points before the scope definition. So that's easy enough. Scope changes in construction. We know that designers are now designing more than ever in 3D, so we can visualize those scope changes in the model and identify them easily. Unforeseen conditions, we can go around and mark up changes in ground conditions, changes in logistics strategies in the 3D model and communicate those with the rest of the team. Pricing methodology, we could communicate changes in work packages throughout the model. If there was an issue with a certain supplier, we could move some of the materials to another supplier and then again communicate quickly with the team the wheres and what fors of that change. Time impact and material delays. what if these materials aren't going to be arriving on site? How does that change the logistics strategy? How do we communicate that with the team that needs to know and get those materials put in the right place? So back to identification. So the typical way we do things at the minute is we identify things on a drawing, we evaluate them, that creates a marked up drawing potentially and some paperwork, then we review them, another marked up drawing, some more paperwork, and then we act upon them, which normally involves more marked up drawings, more paperwork, and then the actual act of performing the change on site and delivering the change. And then, heaven forbid, we end up with a dispute, which then ends up in more and more paperwork. And every single one of these pieces of paperwork is a contributor to that 41% of failure, because each one of them has a time and a cost impact. And the change itself is a small part of the cost and the time impact, and it's actually the delivery of the change that makes the difference. So what we really want to do is create workflows that can tighten up that time to information and time to action. So a study was done a few years ago around practitioner preferences for construction communication, and they found that 58% of construction professionals found it easier to digest information in a 3D format. And the reason for that is it minimizes cognitive effort. You don't have to spend the time to understand the drawings. You don't have to look at different projections and worry that you've missed something. There's a clear information transfer. I know that when I highlight something in the model and I send that hyperlink to you and you open it, that you're seeing the same thing and you're seeing it in the way I intended for you to see it. Collaborative review. The interesting thing about these modern data systems with 3D models, like Andrew was mentioning earlier, is that you've got a point that you can attach data and comments and information to. So if someone dislikes something, they can comment on it and it's all tracked and traced. We can quickly germinate concepts, which leads to up-to-date understanding. You know, if we update a model and issue a hyperlink to everyone on the project, we can be confident that within a day, they may have some understanding of that change and how it's going to impact them. And if they have an understanding of that impact and that impact needs to be communicated back to the owner of the change, that can be done in a seamless way, rather than disrupting a 2-week process of managing that change, all to get the pricing back to the client or the other party within the designated time period. So that's all I'm going to cover this afternoon. This morning, sorry, and I'm going to hand over to Bogdan. And really what I just wanted to do there was just seed a few ideas of how 3D models can be used, and then Bogdan's going to show off a few of those processes, and then there's a few others that that I've spoken about which we don't have time for today, but if anyone's curious they can get in contact with us, sales@3drepo, and we can follow up with some more demos. So over to Bogdan.
Thank you, Matt. It's a very good presentation. Let me just bring my screen up. Hi, everyone. Good morning, good afternoon, good evening, wherever you may be. Thanks for dialing in. It's nice to see such a good turnout. And the topic that we're discussing today is change management. We obviously covered the philosophy and understanding of the change management presented by Matthew. Andrew showed you a bit of 3D Repo, what it is and how it works. Now let me show you how change management works exactly in 3D Repo and what features are available to your disposal to make your life easier, essentially. Okay, so the most important thing is, as 3D Repo, right? What we're trying to do is we're trying to simplify the workflows and also give access to as many people as possible who are involved in the project. What we mean is that we don't just store data in the cloud, we actually give you access through a web browser. So for instance, in this case, I'm looking at my web browser and I can just head over to this project that contains some information about the project that I'm involved in. Now, model changes, right? They happen frequently. They happen across different disciplines and they happen across different file formats. So tracking those becomes really, really complicated at times. The way we do it, we actually store a revisioning system. And what's really nice is that we do it across multiple file formats. So for instance, if we look at this structural model that contains several revisions, here we have all the history in the sense of where it came from, who uploaded it, what changes they tagged, what file format it came in. if we just jump straight to this model, and I can show you how exactly we can look at the differences between the actual revisions. What's really nice in change management through your repo is that you have access to previous models, you have a full audit trail. Frequently in the past, when I worked in big projects, I would often receive different models of various file formats that I was not able to compare with each other, or perhaps I never had access to the original model, so I don't even know where the changes happen or if they change something that I have requested. What we try and do is we try and simplify the workflow. Let's say I pick up a new revision from the structural engineer, and I just want to validate and make sure that the changes they've made are the changes that I'm expecting, and they're not just going off and starting to design things that will have a knock-on effect to MEP or architecture discipline. So for instance, if we go into our compare card and look at the 3D Diff feature, in here you're presented with the option to go across as many revisions as you like. So, but let's keep it simple. Let's say we compare revision 5 to revision 4. What we do is we calculate the geometric changes. So it's regardless of the file format. We are simply looking at where the geometry is changing. And that's the most important bit to us. You know, seeing two elements highlight green and red, telling us something's changed here, doesn't really tell us what exactly is happening on the project, or doesn't highlight the change in context. In here, we can quite easily and quite clearly visualize where the changes are happening exactly. We notice that there are slab openings being added. We notice that there is a new, perhaps a slab type being provided for the balconies or something like that. You can check the data as well if you want to click on those elements. But most importantly, you can actually pick up all those minor changes that are hard to spot at first, right? So for instance, look at this. We have a column in here that changed the depth of it, right? So if we look at previous revision and then we jump to the new one, we notice that there is a change. It might be hard for us to notice it when we first open the file, look at it and say, okay, it's changed. Or if it just simply says this object changed. But what exactly? Has it gone wider, taller, deeper? In here, we can actually see exactly that it's the depth that's changing. Then if we want to, we can click on the element and realize that, okay, perhaps they're using different column type. It's 350 by 650. That's not what we specified. If, for instance, this is an issue to my project delivery, I can, you know, without the effort of double handling, you know, sending emails or taking screenshots or using some additional, you know, softwares to do that, me without any knowledge how to use bespoke desktop application as such, I can quickly open the model, check if there are any changes, pick up the change, not have to wait for a specialist to raise it and then use some sort of plugin to push it somewhere. I can quickly raise it right here at the same time. I can say column depth. I can say check this, you know, I want to raise it with the engineer, right? Can you make sure that the drawings are updated, right? So this is my message in here. I can assign it to actual structural engineer as well. Here's, I can say that this is actually a problem with diffing that I've just picked up, and it's a high priority, right? We're about to pour columns on site, and suddenly we notice there is a change in design. Are they going to address it on their construction drawings? You know, if you want to, you can add additional markup, add arrows to it or whatever you want it to be. Here you go. I'm pointing to this column. There it is. Job done. What's nice is that once I save it, the person can quickly jump to the context themselves and actually understand what is it I'm trying to share with them. Maybe they weren't aware of the change themselves. Maybe the team just went on and did it, right? So these things are really useful for when you're looking across different disciplines, right? So this is how you raise an issue that you might pick up with geometrical changes within the model. You can look at anything. It could be, let's say, a structural model. It could be something more specialist. Let's say, for instance, we have specialist lift, right? They've designed some sort of equipment to go in my lift shaft. And I just want to compare how is it progressing because we're about to, you know, order this and deliver it on site. Using 3D Diff, we can quickly start realizing that, okay, they're making changes, they're changing the width, the openings, they're actually, you know, as you notice, starting to change some structural framing. You know, this is what it was before, this is what it is now. elements are moving, elements are changing. You can see exactly where they are changing, rather than just seeing the beam flag up red and then scratching your head thinking, where exactly is it? You can actually bring it into a context. So for instance, let's say we have a federation such as structure and architecture, right? We have a work package, or maybe let's maybe simplify. Let's do structure and interior, right? This is where the lift shaft is going to sit. Let's say we take the specialist lift shaft. What's nice is that this could be an IFC file from specialist subcontractor, but we also can merge it with the interior and structural model. That could be Revit file, right? So what's really nice is that now we are able to track those changes in context across multiple file formats and disciplines also. We open our compare card as we did previously. Here we can say, okay, I just want to keep my revision 5 for structure, but I want to compare the actual specialist lift. Once I activate it, we're loading the previous revision for specialist lift design. You can't see much because obviously you're not looking at the change itself, but that's not a problem. I can actually drop a section plane in here if I want to. And let's just cut it across to where the core is. Here you go. Now, in context, we're able to see everything quite clearly in the sense of where it's changing and how it's changing and how it works in relation to, let's say, structure or architecture. Are those lift overruns fitting in the slab openings and things like that? So once again, it's the ability to simplify the workflows, not rely on those specialists, creating the rule sets and things for you. You can quickly merge multiple file formats and jump straight to the point if you need to do so. We can jump onto another workflow that I can show you around. Is, for instance, let's say we received a new MEP model. Perhaps it could be MEP and interior package, right? If we jump into this one, we can actually see that somebody raised some issues to do with the actual change that we're talking about, the geometric change. Perhaps somebody raised the issue in the past, right? We start seeing that there are some issues in here. We can even filter for those, understand that, okay, are those all to do with diff or not? Okay, those are not even tagged as a diff, could be requests for information, but nevertheless, let's check them out. So here we go, we click on the pin, we jump to here, and then we start realizing that, okay, it looks like as though it's probably fixed. So we start realizing that in the past, what they told us the problem was, in fact, is the cable tray that's not fitting, right? Now we realize there was a context, people started working on it, they shared information, PDF plans. They could have attached some sort of layout plans that were directly related to this. But me being tagged as an individual who raised it for approval, I can then say, okay, well, I can see that this actually shifted, right? But, it's all great, but I actually want to understand where it's shifted and how it's shifted, right? So they've made this change. Has it got any knock-on effect on anything else? I may choose to say, okay, well, it's closed, it's fixed, this exact change. And what's really nice in here is that you don't just automate this workflow by saying, check, is the element there, done. What people don't realize is that those automated checks for changes could have knock-on effects on alternative routes around the building for MEP equipment, anything like that. Similar to that, let's bring up our compare card and then say, okay, well, let's just have a look at MEP and let's see what changes there are. When we compare it, and I'll show you that 3D Diff actually really helps to understand MEP changes rather easily. Because unfortunately, MEP models get really heavy and complex, especially when there are lots of changes happening. For instance, let's say we received our new model revision and we're just looking at it now. It's hard to understand where the change came from and what it includes, right? But when we go to comparison tool, we start realizing, okay, well, there's some sort of, drainage pipes in here. There's some sort of additional pipes in, let's say, our risers. But you are starting to see not just the object suddenly flagging up, it's the change. You can actually see where the change is happening, right? This is where it was before. This is how it is now. You realize there's extra additional room there. There's obviously a shift between them too. So you're losing this pace as well. And then looking at things like even, cable trays or something like that, right? There's additional new pipe in place. You can see exactly how it reflects across the actual design. You can pick up any minor geometric changes, and once again, across different file formats. So this is particularly useful for, let's say, you are in stage 4 or 5, where you inherit Revit models, but then you suddenly choose to export IFC files. How can you track and make sure that the MEP model is still as it is when it was originally submitted in stage 3, right? So we can do that in here also. If we jump back, and I'll show you another little thing, it's really particularly useful for, once again, bringing the change into context so you can actually understand why that change is happening. Just seeing the element changing doesn't really tell me much, to be honest with you. So if we, for instance, jump into apartments layout, quite frequently designers make changes, but we don't really understand why they make those changes or how does it reflect something else. Let's say we're looking at these apartment layouts, right? So it's a small little model where we have a furniture model, we have an interior, and we also have some MEP apartment layout model, right? So there might have been some changes to this model, and we can actually check that in context. So once again, if I just keep everything as it is in there, and I'll keep my structure on 5, I'll just compare my apartments. There you go. Not much I can sense at first, to be honest with you, but then I start realizing there's something red in here. Something has changed. Okay, there's additional equipment that's included in here also. It might be quite hard to understand the context of that in 2D, especially let's say if I drop a section pane in here, and I'm just trying to understand what change is happening and why is it happening. As we're cutting through this model, you'll realize that, oh, the change is happening is because it's a kitchen unit, right? Maybe they rearranged the unit. And also the main reason why the changes happen is, I guess they shifted these pipes simply because, as you can see, that the pipe was sticking out here originally in first place. So once again, it gives us a little bit more context, and it's a lot easier to track these changes and understand why they're happening, right? So this is our previous revision. This is our new revision, and now we can actually see where exactly this change is happening and how, all those minor tweaks and movements for these pipes as well. We suddenly start realizing it's shifting in here because it's maybe getting closer to the wall, so they need to move it away. As we go further in through the building as well, we start noticing, okay, there's a bit of ductwork that's changing its shape completely. Why? Because we realize that it's actually conflicting with the slab right above it, right? You wouldn't be able to install it. Hence, they're actually making this change. When you look at it in 2D drawing, you see there is a change from above, but you don't really understand why that's changed. Now you can actually see that the change was driven by other element that was conflicting with it. Okay, perhaps enough of, let's say, 3D Diff to track your changes. Let's have a look at how maybe you can track changes using smart groups. So smart groups are really good. Let's say, for instance, we jump back into MEP and interior, where we're looking at 3D Diff changes and things like that. We can use smart groups to either help us build the context around us, understand what each element is, what's the purpose of it. So for instance, once I have this model loaded, I also have some smart groups in here, right? I can override them all if I want to quickly and bring the colors in and understand, okay, we have some hydronic supply, we have some domestic cold water, we got some cable trays and things. Okay, so we can use these groups that simply run the rules, nothing too dissimilar to, let's say, creating group sets and things like that in Navis or Solibri. Right here in our model. What's nice is that everyone who works on this project and has access to the model has access to these groups. They don't have to, scratch their heads, ask colleagues to learn how to do it. It's rather simple. You pick a parameter that's available for you, and then you can create those groups. But what's really nice is, okay, we can use them to bring some context, but we can also use them to track changes. So if I, for instance, jump into my, let's say, interior model, and for instance, I'm done with tracking changes in 3D. I actually want to track changes in 2D, such as data. We can use groups, right? So this is our model interior, and we have created some groups. What we're looking for is, okay, I just want to have a look. We have 1,500 door elements. Let's just have a look at those in the model, of which our interior are these. Let's isolate those. But now I want to validate some information, right? I want to know which doors have fire rating. Okay, these ones. But we also notice there are some doors that don't have fire rating. But on top of that, we notice that there are doors with fire rating parameter, but the value is 0, right? Okay, here you go. We can actually bring the context to our model and help us visualize that information and realize, well, who's working on this apartment layout? Why have they not added the parameters and things? You can raise an issue from this if you want to, straight away in here, without wasting any time sending it somewhere via emails or some sort of plugin or anything like that. What's nice is, once again, if you're working in design authoring tool, you can bring these issues back in. But what's also really good is that these groups, they work automatically. Once you set them up, a new model revision arrives, it automatically runs the rules. You don't have to, rerun it or reactivate it. It does it on our servers. So every time there's a new revision, you see what's the actual state of affairs for the latest piece of information. If you want to, you can jump to a previous revision if you wish to see how it was back then. But let me show you something else. So if I just bring up a tool called Power BI, I'll show you an example of how else you can validate this data, right? The real beauty is, okay, we have access to this data. There are various ways how you can visualize it rather simply, cleverly. And I think it really helps those individuals that are not super users, in 3D design authoring tools or don't really have a computer science degree to do anything complicated. But if you want to venture out, you can do so. For instance, Power BI is just an example. You can do this with Tableau, Airtable, whatever you want, you name it. If I just open up a file I have created in here, and what we'll look at is, we'll look at changes across model data, but we'll look at it in our own custom way. So if I just jump back to TeamSpace, we have this structural model in here that has multiple revisions. We can actually go across those revisions, and using APIs, we can tap into 3D Repo and pull the information out. We can pull data out if we want to without even opening the file. This data is accessible to you live, so as soon as you hit refresh, it's there. What's really nice is, hey, now I have one project where I have multiple file formats all floating about. I can see 3D changes and raise them in the browser. But what if I want to have track of my own? What if I want to do my own custom calculations? Like here, I can go across multiple revisions, understand what parameter values exist. For instance, I want to check how much volumetric will be required for my, concrete core walls, or how much volumetrics are there for my concrete columns, to understand, how much volume will I be required to pour on site, and how it evolves over stages. It's really useful data. It's really useful information. You can do it for data. It comes in a table form that you can play around with however you like. Additionally, you can do that to even things like smart groups if you want to, right? So if I jump into, okay, let me just bring this one up. If I just jump into, let's say, smart groups, right? This is my template in here. I'll show you that you can run those rules for smart groups also. So you're not just limited by what there is on the web browser, right? If you want to venture out and do your own custom solutions and calculations, you can do so, whatever it may be. Just pick it up and off you go. The same thing is applicable to anything else, right? You can build your own custom issues dashboards. You can build your own custom dashboards for your rule checks, for the smart groups to understand, which items are compliant, how many of them there are, who creates these rules when, how many objects there are in the model. You can do so. And if you want more help, obviously, you can always go to your icon in here and click on the support center. In support center, there's a lot of content, sample templates you can use. And once again, don't forget about APIs, right? These are the things that allow you to do anything you want with 3D Repo, even outside of 3D Repo. So I think that's about it. I will conclude here because I don't want to overwhelm you. I just wanted to highlight how these workflows may be incorporated in your current projects and in 3D Repo. And I'll hand it over to Steve Burton, who has a really exciting presentation about how it's really used on real projects, rather complex ones. So thank you very much, everyone, and enjoy the next presentation.
Thanks, Bogdan. Yeah, so we're going to hand over to Steve now. I just wanted to say, just quickly jump in and say, we have had some questions coming in. I'm saving them till the end. I'm not ignoring you. But if you do have questions on any of that or what Steve's about to present, do keep them coming in. It would really be good to get a nice conversation going at the end. All right, Steve, over to you, mate.
Thanks for that, Bogdan and Matt. That was a very good introduction, and I'm hoping that I can bring both those aspects that you guys spoke about into a real life example that is being designed and built as we speak. So I am Steve Burton. I am the digital construction lead for Atkins, and I look after the implementation of technology and software onto our major project portfolio, with Hinkley Point C being one of them. And within this presentation, I'm going to give you a brief introduction onto Hinkley Point C, as certain people outside the UK particularly might not have heard about it, and what Atkins' scope is within this contract. And then I will start to discuss the overarching BIM workflows that we use on the project, before talking more in depth and more about the workflows, about how we've implemented 3D Repo, and particularly the 3D Diff technology of 3D Repo within validating the models, validating any change management, and also within the quality assurance processes. So Hinkley Point C is a new nuclear power plant being built in Somerset, UK. The construction started in about 2016. It's going strong. Obviously, the current pandemic has slowed things down a little, but they're really ramping up. And at its peak, we will have about 6,000 workers on site and about 20,000 people within the entire supply chain working on this project. And when it's complete, it will be capable of producing 7% of the UK's energy needs, which I believe is about 6 million homes. This is currently the largest infrastructure project in Europe at the moment, and the project has just broken the record for the largest concrete pour in the UK. So they poured 9,000 cubic meters of concrete, which had 5,000 tons of rebar within it. And within the scope, Atkins are the detailed designer of the conventional island and balance of plant. So that is buildings such as the pumping house, the turbine halls, and some ancillary buildings around. There's approximately 20 buildings within that scope. And we will do the detailed design and analysis, and we will produce the BIM construction deliverables out the end of it. So we will produce concrete models within Revit, and we're also providing fully 3D rebar models that are all coordinated and clash resolved with all the embedment items to very tight tolerances. And to give you an idea of how many embedment items, we can easily have 20 to 30,000 embedment items per building. And you know, this is a nuclear power plant, so the density of reinforcement is exceptionally high, that we are approaching, you know, 300, 400 kgs a meter cubed. So it's a lot of congestion and a lot of coordination there. But within this, I'm particularly going to talk about the Revit model and the concrete model. Because within the production life cycle, what currently happens is EDF, who are the client, they produce all the civil works layout using a Riva plant. That is predominantly because this structure is as a power plant, so the plant dictates the concrete layout and concrete outline. So above everything, getting the correct plant and equipment in there is the most important, and that will dictate the structural, layout rather than the structural layout dictating the plant and equipment. So they use PDMS to do all of their work. They will then provide us an NWD, a Navisworks extract from the PDMS model. This then gets transferred across to Atkins, and this becomes Atkins scope. So we will then use Revit to start producing our concrete outlines and the embedments and all the embedded items, halfing channels, door frame, sleeves, pipe work, everything like that will be produced in Revit, and the model will be developed in Revit. There's also a side work stream that comes out. So EDF have developed a tool that will convert from PDMS into Tekla, and they will provide a Tekla model to us, as in the concrete outlines, and then it is up to then Atkins to start, in basic terms, filling that with reinforcement. Obviously to very strict rules, but we will add all the rebar in there. And I know there's probably many people out there thinking this is a little bit mad using all these different software. There's lots of reasons and lots of history behind why certain software is used at different times. Yes, ultimately it'd be best if we used one suite from start to finish, but I won't go into them. But there is reasons why we've been pushed, or this is the right route for us to go down. So obviously within this conundrum, we can see that we've essentially got three different models at play. We've got the PDMS model, we've got the Revit model, and we've got the Tekla model. And we need to ensure that all these three models are compliant against each other. And this is where 3D Repo really comes into place, to firstly validate all of our information and to ensure it's correct. So we can take the Navisworks model, upload that directly to 3D Repo. We can bring the Revit model directly up to 3D Repo, and also the Tekla model up to 3D Repo. The way we normally do it is we normally do these via an IFC format, and that is because within the Hinkley Point C project, the IFC is the formal deliverable, and in certain parts that is a construction deliverable. So that's why the IFC is quite important to us, and it's very important that it's validated. So within 3D Repo, we can bring all of these concrete geometries in. We can use also Navisworks to change the coordinate systems, because unfortunately we've got different coordinate systems as well. But luckily through Navisworks and the plugin for 3D Repo, we can change the coordinate system, so that removes that problem. And we can run 3D Diff, which will let us know if all our models align with each other. And this is a very, very quick way for us to see, as Bogdan presented earlier, some really minute changes in the models. It could be a slab maybe converted when we modelled it 50 mils too thick. That's something that might go unnoticed, but those tiny little changes get picked up, and we can then ensure that it's 100% validation between our input model, which is the important layout, and the Revit model, and then obviously the conversion that we get from PDMS to Tekla. We can then ensure that that conversion is 100% correct, and there's no missing elements or no incorrect conversions between the two. So this is a really important first step, where we've, at the end of it, using 3D Repo, we've got a validated model. Now, obviously, change comes around. It's unavoidable on all these massive major projects. And also sometimes change isn't such a bad thing, because at the end of the day, being able to make changes throughout the development of design development can result in a far superior product that can be built faster and cheaper out on site. So for the project, sometimes changes are actually a positive thing. I know change is always seen as sometimes a negative thing, but it can be positive. And by using 3D Repo, we can definitely start to turn a little bit more of those negative connotations around it to be a positive way, and a positive way of managing change and implementing that successfully on a project. So But we will get, when a change comes around, we will get an updated version of the PDMS model in NWD format. And this will be accompanied by a change note that will say what changes have been made within the PDMS model. However, not taking those all at face value, we're able to run through this very quickly through 3D Repo and identify if all those changes are the only changes that were there. And then if there's other changes in the model that 3D Repo identifies, we can then start to question or query those changes because potentially the were changes that shouldn't have been made. Maybe the modeler made that change by accident, or they made the change wasn't correct and maybe forgot to revert back. So this is a very important step of actually being able to identify all the change and report them and have that conversation with the client in a nice 3D environment, whereas we can tag up very quickly and very easily, and we can go through these changes one by one and say, these are the ones on your change report, that's fine. These ones were not on your change report. Were these meant to be changes, or were they maybe some mismodeling, or maybe it's still areas that are sort of work in progress? And then that allows us to then have very quick, change and impact assessments that we can do. So after we've assessed the change at this point using 3D Repo to compare the two different revisions, we need to then start implementing it. And implementing the change is obviously the key is to communicate out to all the users to let them know these changes have came in. These are the changes that we need to update, and these are the areas that maybe we can ignore for now. So we are able to then tag everything up within 3D Repo using the issue and the issue management tools, and generate a change report. So from 3D Repo, we've got a marked up 3D model. We can turn that into 2D information through the change report, which then can be provided as a snapshot in time to the modelers. So they can use both the change report and 3D Repo to identify those change areas. But the ability to create a 2D change report really enables us to take a full audit trail of all the changes and all the changes we've implemented and have a record for them at that snapshot in time. So this provides a really quick and easy communication tool, which we can then bring into Revit, make the necessary updates within Revit, and then also bring that Revit model into Tekla to make all the necessary updates to the reinforcement if necessary. And again, after we've implemented all that change, we can bring these models up into 3D Repo and compare them again. So again, at the back end of this, we end up with a validated model, and which is great. It's a big, easy tick in the box. And we're able to then update all the comments or the issues to say they're closed. Again, create that change report, which then is a record that we have closed off all these comments, all these changes that we can then use as a communication tool between ourselves and the client to let them know and provide a record. Also within the general quality assurance process, obviously we want to ensure a high quality product that is right first time. As I said, the IFCs and the models are used as construction deliverables. So these are equally as important to be 100% correct as the drawings are. So even between revisions, so when we are maybe not doing changes, but it's just regular design development or updating our own designs, we're able to review 2 changes within the model to ensure that they are correct and match. We've also been on projects, or at least I have unfortunately maybe been on projects where elements have been deleted by complete accident, nobody's fault. It's been deleted, and nobody's picked it up because it shouldn't have been deleted. no one had communicated it had been deleted, but they didn't check because they were busy checking all the other areas that had developed, and that gets so far down the line. Luckily, in my experience, we managed to pick it up before it got to site. But you know, I have heard of instances where designs have gone to site, they've gone on site and said, "You're missing a column." At that stage, it's too late. It's going to be expensive and costly to fix. So within 3D Repo, bring it into your regular quality assurance process and just checking every model, each revision, very quick to run. It gives you that confidence that model is right first time, and that the changes that have been made are the only changes that are necessary, and it allows you to have that sanity loop just before that model gets issued to ensure it is 100% correct, and in there. So that is I'd say a 0 to 100. So overview on the work and how we're using this on HPC. But I will say it has been a very valuable tool to enable us to effectively manage the change that's come through, and we do, by nature, obviously, we do receive quite a lot of change, and this is probably the exemplar of a project that I've actually seen manage a change and manage it as successfully as it has been. So I would just, you know, when I'm closing here, I would just like to open the floor up. Please ask any questions anyone has. I'll be more than happy to answer them as best as I can.
Brilliant. Thanks, Steve. We have got a few questions for various people, so I'm just going to go through them in no particular order. I guess this one, maybe Matt, maybe Steve as well, you might want to jump in on it, but what about reviewing drawings, PDFs? They're still core deliverable for most organisations. If you're looking to get this out to a lot of industries, maybe you should consider this. So I guess it's Matt, it's a product management thing, but Steve, if you have anything to jump in on that with as well, please do, feel free, how you're managing that process.
Yeah, so much like models, obviously we need to compare changes within drawing files. There is a lot of similar tools available for DWGs. So the latest AutoCAD has a DWG compare tool, for instance. So we have a similar workflow for drawings using that product, but for us, because our drawings, our quality assurance process is get the model right, the model's 100% signed off, then we produce the drawings. So if we manage to capture everything within the modeling phase, and go through the QA process effectively, it tends to mean that our drawing phase is most set around presentational type issues, and making sure that the drawings accurately match the model.
That's good, and just to follow that up from a platform perspective as well, I think it's an interesting point, and I think 3D Repo, what we've strive to do is be the best at managing 3D elements, and we based on Andrew's slide earlier, you can see that we integrate with all those other platforms. So anywhere where you want to manage your 2D, we can integrate with and pull things and share and pull in and out. But we've sort of pointed our laser beam at 3D models in particular.
Okay, brilliant. Thanks, guys. How are the models loaded into 3D Repo? This particular question is around project-wise, and can they be automatically synced, or is it a manual push to the 3D Repo engine? Again, Matt, I think that's probably for you.
Yep. So again, back to the point around the APIs. This is one of the reasons why we think having this full suite of APIs is really useful, because we kind of give the platform to our customers, and then they can do whatever they want and add things in. So at the moment, we integrate with we have an integration with ASite to automatically push 3D models from ASite through to 3D Repo. We also have an integration with an early integration with Microsoft Flow to pull things from SharePoint potentially and Azure document storage. And then in terms of project-wise do have an API. It's a C# API. So with some amount of effort, we could start pushing models from ProjectWise to 3D Repo, and we do that on a project by project basis. So if you come to us and say, my data is going in here, and every evening I want it to sync up to 3D Repo, we can help you with that, or we can help you find someone that can help you with that.
Okay. Brilliant. How does 3D Repo track changes on particular component part between different versions and different models, PDMS, Revit, Tekla? Has the component the exact same name? I can answer from it, but Steve, do you want to answer that from your perspective? Does the component in each one have the exact same name?
It doesn't, no. Well, I mean, it does actually, but 3D Repo doesn't compare through naming, it compares through geometry. So every object has got the exact same geometry, and that's how it compares them. We do have other systems set in place to ensure it's got the exact same name. So there's a whole coding system that we have to follow, and we've got other systems that ensure that between all the three models we have got the exact same coding system. But if we were to upload, for instance, without the same coding system, 3D Repo would still be able to compare those two geometries.
Yeah, brilliant. I think I'll just add to that, because there's a couple of other questions on here that sound like they're more from software developers than construction professionals. So if that is the case and you want to know a bit more about the technical side of it, please do drop us an email. I don't want to get into it now with people who aren't software developers, but the diff stuff is visual. It's not a kind of calculation. It is a visual check between geometry, not using any of the data behind the model for 3D diff anyway. Right, let's find one for Bogdan. Bogdan, can issues be assigned to a particular person or team? I think we kind of covered it, but is there something you can quickly show just to reiterate that point of how that's set up and how it can be assigned to people?
Hi, yeah, thanks, Andrew. It's pretty straightforward, yes. You can, we have a very granular user management system in place. So what's really nice about that is that just as I was showing you, let's say this is a demo project, we have work packages, models with various revisions. Obviously, you can see where these revisions come from, what file format, who uploads them. But also when you assign issues, like for instance, let's say there were some issues in here, we can go to our issues and risks board. We can see that I assign it to a specific group. It could be, let's say, a discipline, could be a team, could be an individual, and that's all done through user management. You can go very granular to project level specifics if you want to, where you can, give as much permission as you want to individual or a group, but also you can create these specific jobs and roles that you can then assign to users. So the answer is yeah, you can assign it per group of people, discipline, or individuals. It all depends on how you choose to structure your project.
Yeah, there's a question about access control, which I think you've how do people get into the right parts of the model, and how do you restrict what people can see? So yeah, things like work in progress and stuff can be set up using the permissions with different areas and what you upload to those different areas. Yeah, so do models have to be converted to IFC first, or can you read native models readily? So 3D Repo will ingest IFC, it will also ingest a native Revit file, it will ingest a native DGN file, and there is a Navisworks plugin. The more gaming type stuff like FBX and OBJs are also supported as well. Do you provide a history of changes? Not unless you've identified them and put them into an issue. So the issue becomes the history. There's a history of things that people have said, and there's a history of the changes that have been created as an issue, but it doesn't, because of the way it inherently works, it doesn't give you a list of all of the changes that have happened. It's a visual tool at the moment. Well, that side of it anyway. The stuff that Bogdan was showing with the Power BI with querying the data behind the model to look at change, that is more something that can give you a history. Could you explain the major limitation of IFC4 on capturing all the data requirements? Not quite sure who to give that to. Was that in response to something that you said, Steve? I don't think so.
No, I'm not too familiar with the IFC4. To be honest, we use predominantly IFC 2x3. So yeah, no,
Yeah, I think
unfortunately can't answer that.
It's probably a more complicated question for another time. But if someone wants to get in touch with us, we can run through that. I think the other one is to follow up an earlier one. Is there an on-premise version of this? We can deliver 3D Repo as on-premise or on your cloud service of choice, as per Andrew's slide earlier.
Yeah, can 3D Repo compare metadata changes? Obviously, that was something I think Bogdan covered. So if you want to know more about that, do get in touch. But yeah, it's done through querying the database and then looking at it in tools like Power BI externally at the moment. Okay, I think we're pretty much coming to the end. Have you worked with Hexagon, Intergraph, PPM Suite, Smart Plant 3D? We don't have any native support for them, but I believe most of those formats are supported through Navisworks, so that's how we ingest that data. I think we did have one project with Smart Plant data coming across, and we put that in that way. Could the engine be used as a management flow system where comment gets set by API and then diff be exported by the API? It's an interesting idea, Matt. And any comment on that? Maybe something to follow up.
So you can set comments and everything via the API, and you can export a diff via. You can export the issues that are associated with the diff via an API, but the diff tool itself works in the browser. So at some point you will have to have someone, you know, with a human eye looking at the diff for the time being. But otherwise, a lot of the other 3D Repo, in fact, diff and clash are pretty much the only area of 3D Repo where that's true, and the rest of 3D Repo can work as a completely headless kind of management tool within an API workflow.
Okay, I think we've pretty much come to the end. I'll just have one last check at the end. Could 3D Repo deal with large models? Yeah, it's all relative. It's not really to do with the number of parts. It's to do with the limitations of your web browser and your graphics card. But do feel free to get in touch if you have something large that you want to try, and we can see what we can do for that. Okay, I think that's about it. Thanks so much, Steve, for joining us. Thanks, Matt and Bogdan. If anyone does have any more questions, please do drop us an email at support@3drepo.com, and we'll get them directed to the right person and put you in touch. And finally, on the recording, that's going to be processed now over the next hour or so, and we'll get that sent out to everyone that's attended, so you can share it as to your heart's content. Thanks very much. Cheers, guys, and we'll see you all on the next webinar.
Thank you very much, Phil.
Thanks all.
Bye-bye.
Cheers. Bye now.